Hey guys, welcome to my channel. So today we're going to do a quick review of the last unit of the AP chemistry exam, which is applications of thermodynamics. So this is actually the unit test I took from Khan Academy, and now let's review that together. So without further ado, let's get started. So based on the standard reduction potentials given above, what is the value of E for the reaction that we presented below? Okay, so here, we're gonna see that our zinc is reduced, right? Because, oh, I'm sorry, it was oxidized because it gives out electrons. However, you can see that our zinc was reduced, so we have to kind of invert this value, and silver was reduced. So value E would be firstly the reduction potential for silver, which is 0.8. And now we have to minus the reduction for the oxidized reaction for zinc. So we're going to minus 0.76. So we left with C is the correct answer. Okay. During the electrolysis of water, hydrogen is generated at the cathode according to the half reaction presented above. Okay, so water electrolyzed for 600 seconds using a steady electric current. The volume of dry hydrogen produced during the experiment was this. Okay. So calculate the current passed through the electrolysis cell. So let's take a look at some relevant equations that the test has provided for us. So first, I think I need to find the moles of hydrogen produced first. So you see, for 1 mole of hydrogen, we need 2 moles of electrons transferred. So in order to find the charge, we need to find the moles of electrons, and hence we need to find the moles of hydrogen. So the mole of hydrogen would be the pressure times the volume over RT, the temperature, and the gas constant. So for the pressure, that would be 1 atmosphere. I want to include the units here so that we would not mess up. 0.291 liter over, because we're using atmosphere and liter here, I think that I would need to use this value. So 0.08206 mole atmosphere liter I'm sorry, it was over mole. So these things we can cross out. Yeah, and now we're going to multiply that with our temperature, which is 298. Okay, so that will leave us with I'm going to plug numbers in the calculator real quick. There's something like this. Okay, and now this is our, and we can find the mole of electron transferred. That would be like twice that amount. So we have 0.024, and now we can find the charge. The charge would be, we're going to need to multiply that with the Faraday constant, which is this value. So we're left with something like this. And now we're going to put that over 600 seconds. We're going to divide by 600, and then, well, what we have is 3.86 ampere. I think that, oh, so we did right, guys. It's just the problem of rounding up. You see here that we actually deviated from the answer with this part. I kind of rounded it up to 0 point. Yeah, I kind of round up to this value. Yeah, I kind of like missed on it. So it was a little bit different. Yeah, but like it's still the same calculation. It's just that this is a problem of just rounding up stuff. And as you can see here that it did not deviate that much, right? So yeah, we still did it right. Oh yeah, I forgot. We need to improve our answers. Okay, which of the following lists the signs of delta H and delta S for the process represented above at this temperature and this so the normal boiling point is at this. So well, because it is at the boiling point and some phase change happening, so our delta G would be 0. So therefore delta H plus T delta S equal to 0. And here we can see that well, the obviously our delta S should be positive, right? Because the particle more dispersed, the entropy increases. So we can cross out B and D. Okay? So here, that is kind of like obvious. Okay, moreover, we know that, so for the process representable, so it's changing from liquid and gas, and normally you need to heat up the mixture in order to turn it into a gas, right? Heat up a liquid in order to turn it into gas. So this is 0, right? And this value is positive. And also the value here is also positive. So I think that delta H. Wait, hold on. It's kind of confusing, right? Isn't it? I know why it is confusing, because I kind of like wrote the equation wrong. So this is a minus sign. So because it is positive, right? This one should be positive too. Okay, because since I kind of wrote the equation wrong, I was baffled, because normally you need to heat up a liquid in order for it to vaporize. So our delta H should obviously be positive. So we're gonna choose A as our answer. In an electrolytic cell based on the reaction represented above, which of the following occurs at the anode? So we need to remember rules, and NOx, and red cat. So at the anode, oxidation occurs. So what is oxidation? So let's take a look at sodium. So sodium and chlorine ions. Right, sodium needs to be added an electrons in order to turn into sodium, liquid sodium. Right, however, this one is to gives out an electron. Right. So it's really easy because reduction is the addition of an electron, because the electron is negatively charged. So obviously chlorine is what is being oxidized here. So we're going to choose C. The reaction presented below goes essentially to completion at this temperature. Based on information, which of the following must be correct? So the reaction is driven. So here we need to plug in our so here we need to find the Gibbs free energy in order to find if the reaction is thermodynamically favored. And I'm going to write the equation now. Okay, so this is minus 7 plus 1, 0.1 minus 28 multiplied with, well, for this one, we need to multiply that. This in order to change that into kilojoules. And what we have is something like this. So it's, well, favored. It's thermodynamically favored. And let me see that. Obviously, is favored, and however, you see here that, well, is surely driven by enthalpy, not entropy, because entropy, the change in entropy is actually negative. So I believe that A is the correct answer. Yeah. What can be concluded about the value delta H for the reaction at this? So let's take a look at the equation here. So the value of equilibrium constant reaction resemble. So K at equilibrium is 25. Therefore, the natural log would be larger than 0. It would be positive, right? So this would be positive. Obviously, these two is positive too. So this is negative. And therefore, this needs to be smaller, right? So that's how we do it. I'm going to choose D. And D is the correct answer. Okay. The synthesis of this acid is presented. Okay. We need to calculate the standard entropy change. So we just need to take the products minus the reactants. Okay. And well, remember to include the coefficients in front of our substances too. And I'm just going to pull out my calculator. So we're going to 2 times 326 minus 205 minus 2 times 312. And that would be minus 177. Okay. Based on the information above, which of the following is a true statement about the thermodynamic favorability of the reaction represented below? Okay, so this reaction is actually flipped this one. So our K2 would be 1 over K1, right? So obviously it's going to be larger than 1. So it is favored. Okay, next. For the reaction represented above, the value of delta G is this. The standard free energy formation is this. What is standard free energy formation at? Okay, so we're going to use this equation. I'm going to plug in here. So we have, well, minus 226 equal to the products. So because this is so delta G formation for oxygen would be 0, right? Because it is there is just only one kind of atom in there. So let's take the product. Delta G of the product is 2 times this and minus formation of a reactant, which is, we're going to call it X. We need to find X. And it's really easy. Let's just plug that in our calculator. And we're left with this. Okay, last question. In an electroplating process, 26 grams of chromium metal is deposited from a solution of the chromium ions. So how many coulombs of charge are transferred during this process? So we need to find Q, right? Okay, we're going to do it real quick. So obviously, we're going to write the reaction first. So our chromium ions need to be reduced by 3 electrons in order to turn to chromium, solid metal. Yeah. So here we can find the moles of chromium. So I'm just going to find it. 26 over, well, the atomic mass of chromium. Just let me take a look at my periodic table real quick. That would be like 52. Minus 50. Okay, so that would be 1.5 mole. So, well, the mole of electrons transferred would be 3 times that much. So 1.5 mole. And so Q would be, we need to multiply this with the Faraday's constant. Because 1 mole of electrons has a charge of this much. So 1.5 times 96,485. And now what we have is about this much coulombs. Okay. So basically, this is the end of the unit test. I hope that you guys kind of, well, get the hang of it. We did all the question the right method, guys. The only wrong question was actually because of the approximating, all the rounding ups, that we kind of like deviated from the answer of the website. But overall, we did good. Thank you so much for watching this video, and make sure to subscribe to my channel for more videos like this. Okay, bye bye and have fun.